Hey there, I hope you guys are doing great. So in this video, we are going to see how we can check the correlation between two variables using a hypothesis testing, that is Pearson's correlation test. So guys, if you have not subscribed to my channel yet, click on the bell icon and subscribe to it right now so that you do not miss on anything. So let's begin. So when we want to check the correlation between two numerical variables in a dataset, then we can utilize the Pearson's correlation test. Now for example, I have an insight that with the data that I have presently, and I want to check whether my mileage and the weight has any correlation to it or not. So I will first try to draw an insight either by mathematically calculating it or by visually seeing it with a pair plot. So let's just see. And on executing the pair plot, I will get a graph of this kind. So you can see that there seems to be an inverse correlation between weight and the mileage. Although this doesn't seem exactly linear, but we will come to it in detail in another video. But for now, the topic is to test the Pearson's correlation test. So we see that there is an inverse correlation, but graphically we cannot conclude it. We can only draw an insight. So for having a conclusion with confidence, we have to perform a hypothesis testing. So we will be performing with Pearson's hypothesis testing, and let's see what are the assumptions to perform Pearson's correlation test. So there are majorly three broad assumptions for Pearson's correlation. The first one, the observations in each samples should be independent and identically distributed. Okay. This means that the sample, the value should not have a dependency on another sample of the same variable. Okay. Then our second observation or the second assumption is that in each sample the distribution should be normal. Although we can see that with this graph, we can see individually also that the distribution doesn't seem to be exactly normal. Let's just check with individual distribution plot for MPG. We can see that it is slightly skewed. So this is the right skewed plot, and let us see for the weight. So I get this kind of, so it is also slightly skewed. But here we can assume that this distribution is somewhat normally distributed so that we can apply our Pearson's correlation test. Now our third assumptions for Pearson's correlation test is that the observation in each sample should have the same variance. So now let us check the variance of weight and the mileage. So now to compare the variance of these two, we should bring them to the same scale. So we will be applying scaling to it with sklearn preprocessing min-max scalar, and I'm calling this class, and then I'm going to apply this particular transformation of scaling to my weight, and then I'm going to check what is the standard deviation I'm getting. So we see that standard deviation is somewhere around 0.23 on the scaled sample, and then I'm going to run the same for the mileage, that is MPG column, and then let me execute it, and I get somewhere around 0.20. So it looks like the variance, that is the standard deviation, are quite similar to each other. So we can go ahead with this particular test. Now we are going to draw our null and the alternate hypothesis. So as per the Pearson's correlation test, the null hypothesis will be the variables are independent if the p-values that we obtain after performing the test is greater than 0.05, that is alpha is 5%. And our alternate hypothesis will be that there is dependency between the two variables if p-value is less than 0.05. So this is the null and the alternate hypothesis of Pearson's correlation test. So if it is less than 0.05, that means our alternative hypothesis is true. That means these two variables are dependent on each other, or there is a correlation existing between these two variables. Okay, so we have now our null and alternate hypothesis being created, and we are going to call the Pearson library with Pearson R from scipy.stats. So this is the library that we are going to call, and we are going to instantiate its stats and p-value, which will unpack the values of the results of Pearson's R, and then we will pass these two samples, these two variables, that is the weight and the mileage, mpg, and I'm going to execute it. And then assuming that our alpha is 0.05, that is 5% is our alpha, and I'm going to write a if statement which will tell us that whether this is true or this is false. So what will be my if statement? So if the p-value is greater than alpha, so that means my null hypothesis will be true, and I can say that the variables are independent, that is, there is no relation between the two variables. But if my alpha is greater than my p-value, okay, that is, my p-value is much lesser than the alpha, then I can say with confidence that there is a dependency between these two variables. So now let's execute it, and I get the value of p which is very less, it is almost close to 0, and with 95% confidence I can say that there is a dependency between these two variables. So this is very important in doing ADA or when you are doing feature selection or featureization. So this way we can select our variables which are having very great effect on another variable. So this was in this video. In this video we saw how we can draw insight about a particular variable, whether there is dependency or not, and to confirm that, to say that insight with confidence, we can apply a Pearson's correlation test to know the dependency of these two variables. We also saw what are the assumptions, and we checked the assumptions are satisfying, and then we draw the null and the alternate hypothesis, and then we called Pearson's R package from scipy stats to do the testing. I hope you guys like this video. Don't forget to subscribe my channel Hope in Data Science. I see you in the next video. Till then, bye.